Hey everyone, and welcome. So today we're going to dive into something that might sound a little complicated, but it's actually the hidden language of the entire universe: chemical equations. And trust me, this isn't just boring homework stuff. These are the secret recipes that create everything, from the water you drink to the very air you breathe. I mean, seriously, what if you had the exact recipe for making water? Not just a vague idea, but the precise step-by-step instructions that the cosmos itself uses. Well, that's exactly what a chemical equation is. It's the universe's instruction manual, and we're about to learn how to read it. All right, first up, let's put on our hats as cosmic chefs. In our kitchen, which is, the universe, the recipes we're going to be working with are these chemical equations. Okay, so what is a chemical equation really? At its heart, it's just a super condensed shorthand for a transformation. It's kind of like a sentence that says, hey, I started with this, did some magic, and ended up with that. It lays out the whole process in one neat, elegant line. So just like any good recipe, you've got two main parts. First, you have your ingredients, the stuff you mix together. In the world of chemistry, we call those your reactants. And then, of course, you've got the final dish, right? What you made. We call those the products. Yep, it's that simple. Reactants turn into products. Okay, let's take a look at that water recipe again. What this says is that hydrogen gas, that's H2, reacts with, that's what the plus sign means, oxygen gas, O2. And the arrow means to produce H2O, good old water. So hydrogen plus oxygen makes water. Seems straightforward enough, right? But, if you look really closely, you'll see there's actually a tiny little problem here. Something's not quite right. And that little problem brings us to our next big idea. See, in chemistry, just like, well, everywhere in the cosmos, there are rules. And there's one cosmic rule of balance you absolutely positively cannot break.
And this is the big one. It's called the law of conservation of mass, and it's a fundamental rule of how the universe works. Basically, you can't just create matter out of thin air, and you can't make it disappear either. All you can do is rearrange the pieces. This means whatever atoms you throw into the pot as your ingredients, you have to end up with the exact same number of those atoms in your final dish. No leftovers, no missing pieces, no exceptions. All right, so let's go back to our water recipe with this new rule in mind. H2 plus O2 equals H2O. Okay, so on the left side, the ingredient side, we've got two oxygen atoms, right, in that O2 molecule. But look over on the right, the final dish side. Our water molecule, H2O, only has one oxygen atom. So, where'd the other one go? Did it just poof, vanish into thin air? Well, we know from our big cosmic rule that that's impossible. This means our recipe is broken, it's unbalanced, and now we've got a puzzle on our hands. Which, brings us to the fun part, solving the puzzle. Balancing an equation isn't some crazy hard math. It's really just about tweaking our recipe to make sure it plays by the rules of the universe. And lucky for us, there's a simple 4-step method to get it done every single time. First, you just write out the unbalanced equation. Second, you do a quick count, an inventory of all the atoms on both sides. Third, you add these little numbers in front of the molecules, they're called coefficients, to make the atom counts equal. And finally, you just do a quick double check to make sure everything lines up perfectly. All right, let's put this method to the test with a totally new example, the combustion of methane. This is basically what happens when you light a gas stove or a furnace. We've got methane, CH4, reacting with oxygen, O2, and that produces carbon dioxide, CO2, and water, H2O. Okay, time for our atom inventory. Let's see what we've got. Carbon, one on the left, one on the right, we're good there. But wait a minute, look at hydrogen. We start with 4, but we only end up with 2. And oxygen, it's even crazier. We start with 2 and somehow end with 3. Yeah, this recipe is a mess. So, how do we fix it? We use those coefficients we talked about. By putting a 2 in front of the O2 and another 2 in front of the H2O, we're basically just changing the proportions in our recipe. We're not changing the ingredients themselves, just how much of each we use. So now the recipe reads, take 1 molecule of methane, mix it with 2 molecules of oxygen, and you'll get 1 molecule of carbon dioxide and 2 molecules of water. So did it work? Let's do a new inventory check. Let's see. Carbon, 1 and 1. Check. Hydrogen, 4 and 4. Check. And oxygen? Let's see. 2 times 2 is 4 on the left, and over on the right we have 2 plus another 2. That's 4. Yes, 4 and 4. It's perfectly balanced. The puzzle is solved. Okay, so
Why do we even bother with all this? What's the point of all this balancing? Well, it's because once an equation is balanced, it gets a kind of superpower. It's no longer just a description of something that happened. It becomes a powerful tool that lets you predict what will happen. So let's circle all the way back to our first example, making water. Here it is, the correct balanced recipe, 2H2 plus O2 equals 2H2O. What this really tells us is that it takes 2 molecules of hydrogen to react with 1 molecule of oxygen to produce 2 molecules of water. You see those numbers out front, the coefficients? That 2, the invisible 1 next to the oxygen, and the other 2? They give us this incredibly important ratio, 2 to 1 to 2. This isn't just for making the numbers work. This is the recipe's secret code. This tells you the exact proportion you need. Now, in chemistry, this has a fancy name. We call it the mole ratio. And don't get hung up on the word mole. It's really just a word chemists use for a specific, really, really big number of molecules. Think of it like a dozen, but for atoms. The important thing is that this ratio is the key. It unlocks that superpower we were talking about because it tells you exactly how much stuff you need to get exactly how much you want at the end, with nothing wasted. Because with that ratio, you can do some amazing things. You can predict exactly how many molecules, or moles, of something you'll need. You can calculate the precise mass of any ingredient or product. You can even figure out the volume of gases that are part of the reaction. This is literally how scientists and engineers can design everything from life-saving drugs to the fuel that sends rockets to space. It's all about precision. So think about this. The next time you take a single breath, your body is performing billions of these perfectly balanced chemical reactions all at once. These recipes are literally everywhere, all around us, quietly running the entire world. The real question is, now that you're starting to understand the language, what other hidden recipes are you going to start seeing all around you?